Hello and welcome to Support and Tracking System for Field Testing Legged Robots using UWB and IMU sensors. Here's an intro. Legged robots that are designed to operate within rugged terrain often struggle to support themselves in their development stages. The research for building legged robots for the Appalachian region often includes various test runs that could potentially cause structural damage to the robot when researchers are still developing ways of exploration and climbing. The original design of what we were given, called the Robot Testing Support System, is shown here. It was very top-heavy due to its arch and only had a manual mode for tracking robots. The new design we made is a lot more table-like, as well as utilizing ultra-wideband beacons for tracking the robot autonomously, and is overall much more portable and stable. The UWB beacons transmit short, low-power radio pulses across a large amount of frequencies, which is really good for time-of-flight tracking because we can figure out how far things are from other things just based on how long it takes for the pulse to come back to itself. So the backpack is a very versatile part of our construction. It goes on the back of any robot being tested, and it is equipped with the UWB, an IMU, as well as a microcontroller, and it's all put in a housing. So we can track lots of different things in relation to the ultra-wideband sensors, as well as the gantry and tracking and all of that great stuff. So here we have stationary tracking. As you can see here on the right, we have a data plot showing the position of both the raw trajectory and the filtered trajectory. The filtered one is a common filter that combines the acceleration data from the IMU and the position data from the UWB to create this more accurate reading. And as you can see, it's more accurate than the raw one, and overall it's pretty accurate. Now right here we have mobile tracking. As you can see, this one is more of a shape. This one is a square. And you have the filtered as well as the raw, and you can tell clearly that the filtered is once again a lot better, combining the IMU and UWB data. And it is a 3x3 foot square. This was a little robot running around through this square, and it shows that it can track pretty well. Next, here we have the gantry feet designs. So for different kind of grounds, outside or inside, the gantry RTS is going to need different effectively shoes that it can wear for different places, and one is for tile, the second one is for gravel, and the third one is for dirt and grass, where a tent stake can be tapped into it to keep it secured. So for future work, our system is currently an improvement from the previous one that was built. That being said, we can definitely still improve the tracking of the UWB sensors, as they can have an error of about 10 centimeters, which is quite a lot. We can also make the overall frame about a foot shorter, as it is foldable, but the portability is still challenging as it is difficult to fit in elevators as well as stairwells. Thank you.